Welcome back. This is Mrs. Rewrite with Algebra 1 Honors. Today's lesson is 8.1, Identify Quadratic Functions. All right, guys, so understanding the quadratic function, the parent function. So with the quadratic function, the parent function, you're going to have y equals x squared. So if we were going to do like an xy table, you could do -2, -1, 0, 1, and 2. And if you plugged in 0, you'd get 0. If you plugged in 1, 1 squared is 1, 2 squared is 4, -1 squared is 1, -2 squared is 4. And so you have this nice little graph. It is a parabola. Okay, so that is the parent function of a parabola. Your vertex is that turning point, okay? That turning point. And your vertex is at 0, 0 with the parent function. What is the domain of f of x equals x squared, or y equals x squared? F of x is the same thing as y. What is the domain? What is the range? Your domain is your x values. Your domain is going to be x such that x is an element of all real numbers, right? So you could write it like that. Another way they write it is just go domain equals all real numbers. And another way that you'll end up seeing it in the future is it goes from -infinity to positive infinity. So there's a few different ways to write that, but basically our x values, it's opening up forever. So it's going to eventually cover every single x value. For our range is our y values. Our range is y such that y is what? Greater than or equal to 0, right? It's only the positives. So you can write it like that. Okay. Another way to write the range is that it's going from it's going from 0 included. So we go like this, 0 to infinity. Okay. So parentheses for open-ended, or either parentheses or arrows, like kind of like sideways arrows like that. So they can do it either way. So it's like this or like that. I've seen it both ways. All right. So parenthesis versus a bracket. It includes the 0. It does, and infinity is just open-ended. All right. What symmetry does the graph y equals x squared have? Does it have? Why does it have the symmetry? So it's symmetric over x equals 0. It's reflected over x equals 0. It's reflected over x equals 0. Or over the y-axis, right? Symmetric over the y-axis. The square of any number and the square of its opposite are equal, so the points x comma f of x and -x comma f of -x are reflected in the y-axis, all right? So it's because when you take a negative number and you square it, it becomes positive, so you will always have that nice symmetry, right? That nice mirroring. For what values of x is f of x equal x squared increasing, and what for values is it decreasing? So increasing. So for what values of y equals, okay. So where is it increasing? It's increasing over here, right? When your x values are greater than 0, it's increasing, right? So increasing at x is greater than or equal to 0, and it's decreasing for x is less than or equal to 0. So x is less than or equal to 0, it's going down. And then it's going up, it's a positive slope if it was over here, right? Graph each quadratic function. The graph of the parent function, y equals x squared, is shown in gray. So if I was going to graph this, I'm going to plug and chug. So 0. 0 squared is 0. 0 times 2 is 0. 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. 3 squared is 9. 9 times 2 is 18. -1 squared is 1. 1 times 2 is 2. -2 squared is 4. 4 times 2 is 8. -3 squared is 9. 9 times 2 is 18. You guys see how I just plugged it into this formula? Y equals 2x squared. Now I'm just going to plot the points. 0, 0, 1, 2, insert 1, 2, negative 1, 2, negative 2, 8, negative 2, 8, 3, 18. I can't fit that one. So you guys should be able to see that this is a vertical stretch. This is a vertical stretch by a factor of 2. So instead of it being over 1 up 2, or sorry, over 1 up 1, instead of up 1, 1 times 2 is 2, up 2. Instead of over 2 up 4, it's over 2 up, and 4 times 2 is 8. Right? It's vertically stretched by a factor of 2. All right, so then what do you guys think this one's going to be? Just looking at it with the 1/2. This is going to be a vertical shrink by 1/2, right? So it's going to be like short and fat. This one's tall and thin. This one's going to be short and fat. So let's look. 0 squared is 0. 0 times 1/2 is 0. 1 squared is 1. 1 times 1/2 is 1/2. 2 squared is 4. 4 times 1/2 is 2. 3 squared is 9. 9 times 1/2. 9 divided by 2 is 4.5. 4, 2. Okay, and it has that nice mirroring. So we have 0, 0. We have 1, 1/2. We have 2, 2. And we have 3, 4.5. This one's a vertical shrink. It's being pushed down. Vertical shrink by a factor of 1/2. So instead of over 1 up 1, half of up 1 would be up 1/2. Instead of up 4, half of up 4 is up 2, and so on. Does that make sense? The graph of the parent function y equals x squared includes the point -1, 1, because f of -1 equals -1 squared, which is 1. The corresponding point on the graph g of x equals 2x squared is -1, 2, because g of -1 equals 2 times -1 squared, or 2. In general, how does the y-coordinate of the point on the graph of g of x equals 2x squared compare to the y-coordinate on the graph of f of x equals x squared when the points have the same x-coordinate? Okay, so this is exactly what I was just telling you guys. So we're comparing this to this. All right, so this is going to be my y-coordinate is going to be on g of x. My y-coordinate is going to be twice as high, right? Because you're multiplying it by 2. The y-coordinate on g of x is twice as high as the y-coordinate on f of x, right? Describe how the graph of g of x equals 2x squared compares to this. So it's going to be a vertical stretch, right? It's a stretch by a factor of 2. How does the y-coordinate on the graph of this compare to this? So it's a vertical shrink. By 1/2, where here the y-coordinates on g of x are half the height of the y-coordinates on f of x. Okay, let's look at another one. So now we know that this 2 is going to be a vertical stretch by 2. But what does this negative do? The negative actually reflects it. It's going to reflect over the x-axis, and I'm going to show you guys this. So if I plug in 0, I would have 0. If I plug in 1, I'd have -2. If I plug in 2, I'd have 4 times -2 is -8. If I plug in 3, I have 9 times -2 is -18. If I plug in -1, I have 1 times -2 or -2, -8, -18. All right, so I have my 0, 0. I have my 1, -2. to negative 8. All right, so this is vertically stretched by a factor of 2, but it's also then reflected over the x-axis. You see how that works? So instead of over 1, right, over 1 up 1, it's over 1 up 2, and then reflected. How about if it was negative 1/2 x squared? What do you guys think? This is going to be what? The 1/2 makes it a what? Vertical shrink. So it's a vertical stretch if it's a number greater than 1. It's a vertical shrink if it's a number greater than 0, less than 1. Right? Vertical shrink by 1/2. It's half the height. And then the negative makes it reflected. Over the x-axis. So once again, 0, 0, 1, negative 1/2, 2, 4 divided by 2 is 2, so negative 2. 3 would be 9. 9 divided by 2 is 4.5, and it's negative. Zero, 0, 1, negative 1/2, 2, negative 2, and then 3, negative 4.5. There's a vertical shrink, and it's reflected. Anytime that your leading coefficient is negative on a parabola always has a square. If it's negative, it's going down. Anytime it's negative, it's going downward because it's reflected. Right? If it's positive, we know it's going up. All right, so if we're comparing this with this, what do we know? We know that it's a vertical shrink, right? It's vertically shrunk, and it's reflected. It's going to be half the height and reflected, right? Okay, let's skip down to this little chart. So if my leading coefficient is greater than 1, it's going to be a stretch, right? If it's between 0 and 1, so 1/2, 1/3, 1/4, 1/10, 1/12, it's going to be a vertical what? Shrink. All right, and is it reflected? No, because it's still positive. All right, so if I'm going from negative 1 to 0, so these are my negative fractions, my negative 1/2, my negative 1/3. It's going to be shrunk, right? It's going to be a shrink, but it's also going to be reflected. If my leading coefficient is negative 1, the 1 doesn't really need to be there. It's just the negative. So it just gets reflected, but it's not vertically shrunk or stretched, right? So reflected, yes. It's not shrunk or stretched. It just stays. And if my A is less than negative 1, so say it's like negative 1 or negative 2, negative 10. So then it's going to be what? A vertical what? Stretch. Reflected, yes. Yes. Write the equation for the quadratic function. So if I'm looking at this equation right here, I know that this is going down, so it better have a negative, right? So it's going to be y equals, I know it's definitely negative something. You guys with me so far? Let's look at some of these points. So it says use the point 2, negative 1 to find A. So we know that the point 2, negative 1 is on this equation. So if we have this equation right here, and we're using x and y, aren't we just saying that x is 2 and y is negative 1? 2 squared is 4, so 4 times a equals negative 1. Divide by 4, a is negative 1/4. So y equals negative 1/4 x squared. Let's see if this pans out. All right, well, if I plugged in a 0, I'd have 0, 0. If I plug in a 1, let's see, where does it go perfectly? Like 4 looks like negative 4, right? Plug in a 4. 4 squared is 16. 16 divided by 4 is 4, and it's negative. Negative 4. It works, right? So this is the equation of this graph. So we take this format of y equals ax squared and plug in a point on the graph to solve for a. Once I have A, rewrite it with your A. You can always check by plugging in points. Let's go over to the practice. So, what do we know this is going to be? It's going to be a vertical stretch by a factor of 3. So we know we're definitely going to have 0, 0. Instead of 1, 1, it's going to be 1, 3. Instead of 2, 4, it's going to be 4 times 3 is 12. But if you didn't know that, or you don't want to think that hard, all you have to do is your XY table. -2, -1, 0, 1, and 2. 0, 0. 1 squared is 1. 1 times 3 is 3. 2 squared is 4. 4 times 3 is 12. And then plot those points. 0.6x squared. We know we're going to have 0, 0, right? We're going to do our XY. Vertical stretch or shrink? Shrink, right? 0, 0. -1, -2, 1, 2. 1 squared is 1, so that's going to be 0.6. 2 squared is 4. 4 times 0.6. 2.4. So 1.6. 2, 2.4, and so on. All right, let's go down here. Write the equation for the quadratic function whose graph is shown. All right, so we definitely have a 0, 0, and we have this point right here. So y equals ax squared, right? This is your x, this is your y. 5 equals a times -1 squared. 1a, or a, equals 5. So this is going to be y equals 5x squared. Let's double check. Point 1 looks like it's at 1, 5, right? 1, 5, that works. How about, there's no really other perfect intersections to really look at, but it works. All right, let's do another one. Y equals ax squared. Xy. 10 equals 10 squared times a. 100a equals 10. Divide by 100. A equals 1/10. So this is going to be y equals 1/10 x squared. Let's check this out. So if I plugged in a 10, 10 times 10 is 100, 100 divided by 10 is 10. That works. How about here? It looks like it's perfect here at 20, 40. If I plugged in a 20, 20 squared is 400, 400 divided by 10 is 40. It works, right? On number 8, this better be negative. So if I do y equals ax squared, my y equals ax squared. 16a equals -4. Divide by 16. 1/4. -1/4 equals a. Y equals -1/4 x squared. Let's double check. We can plug in, it looks like 6, -9. 6 squared is 36. 36 divided by 4. What is 36 divided by 4? Is that 9? Yes? So we know we're good. Are you guys getting the hang of this? Okay. So this is a vertical shrink and reflected. Vertical shrink. Vertical stretch. Are we okay? We're good? All right, so your homework tonight is 417 and 418. Please like and subscribe and have a wonderful day.